Hi, how's it going? As I work on my various little programming projects in the background, I just wanted to sit down and talk about a topic which I've been thinking about for a while in the field of education. I'll give you the TLDR, and that is, I'm talking about thinking models, mental models, modes of thinking, and there are two extreme ends of that. On the one hand, we have abstract thinking. On the other hand, we have concrete thinking. Now, both have their virtues, and they can both learn from each other. So, if you are an abstract thinker, then congratulations. You probably do not suffer from fixed mindset. You probably find it easy to pick up new topics and learn them. That's great. You may wish to consider a slightly more concrete approach to your work in order to increase your productivity. On the other hand, if you are a concrete thinker, then congratulations, you probably do not suffer from the same aversion to the physical realm that a lot of high-minded intellectuals have. However, you do run the risk of being just a worker drone who can only do one thing. Okay, so you may wish to consider looking a bit more into the specific things that you do, understanding them more, and focusing on skill building and craftsmanship. So that was the TLDR. Now let's get into the content. Do you know those intelligence tests where cats look at birds on TV? Comment down below. Do you think, like if the cat swipes the bird, is that actually a sign of intelligence or not? I don't know. Because on the one hand, the cat could recognize that's a bird. They can recognize shapes and things. But on the other hand, are they not swiping the bird because they realize that it's a two-dimensional image in a TV? Like, I really don't understand. There's no way, personally, I think there's no way to get in the cat's head. Not easily. But we can do that with people. I remember years ago I was teaching in a high school and we had some exercise, some assignment or something. These students were almost graduating, the ones I was teaching. We were writing a report and the report said, draw a conclusion. Students were like, sir, what am I meant to draw? Abstract reasoning and problem solving, in that case it wasn't there. But it's an important thing to have. In learning, there's something called concepts versus facts. You've probably heard this before. It's been a popular topic a while ago. The idea is that a concept is a piece of information which has meaning and you can reason about it, and it links to other pieces of information. It summarizes information so knowledge can be compressed or expanded as necessary. And on the other hand, you have facts. And facts are just raw information. There's no semantics to them. There's no meaning to them. They don't really explain larger things. And then I guess somewhere in the middle of that spectrum, you have other bits of information like heuristics and axioms. So a heuristic is sort of like a concept, but less rigorous. It's a broad rule for making judgments based on criteria, and it will approximate a theorem. We can say that. And then we also have axioms. So an axiom sort of is a fact, like it's fixed. That's it. There's no debating it. There's really no proving it. But it is used in a lot of abstract reasoning because abstract reasoning alone is not sufficient. You do need concrete facts to ground your theorems on. But the one thing that people don't talk about is that a fact can become a concept. Let's say that I am learning, network programming. That's a new thing that I don't have much experience with. Now, when I'm coming into that field, I don't really know that much. So a lot of it just looks like facts. Learn this, follow this, muscle memory, type this code out, do it this way. But then the more I drill into that, the more I will examine the individual components and start to reason about them, start to understand their links to each other. And then a lot of those things which I previously took as this is just it, them's the facts and them's the rules, will feel more, that knowledge, that body of knowledge that I've been accumulating will feel more like it's mine, more like I can compress it. This sort of ties in with that whole thing of like learn the rules and then break them. So there's that. What I'm doing at the moment is I'm sort of talking around the topic a little bit to expose various aspects of it. Maybe this is entertaining, maybe this isn't, I don't know. But we also have, in my opinion, sort of a spectrum between what I would call the technician versus the intellectual. So a technician is very sort of fixed mindset. They have a job, they know how to do it, they know how to do it very well, right? They could be highly valued, they could be highly competent, highly productive, but at the end of the day, their work is fixed. And then on the other hand, you have an intellectual, and an intellectual will reason about the properties of a problem rather than address the problem directly. Well, maybe to the intellectual, they're addressing it directly. So, for instance, if you start talking maths at me, start throwing equations at me and say, hey, what's an equation that satisfies this some other differential equation or something, then I'll start to think about the properties of the equation, like, okay, is it monotone, is it bounded, is it periodic, odd, even, those sorts of things. Whereas a more concrete thinker might say, oh, it's x squared or something. You know what I mean? Like they'll try to think of examples. And I'm not saying that I'm an intellectual. I am by no means an intellectual. I'll go to a math seminar, I'll see some presentation and I'll think, wow, that's very cool. I'm not going to spend my life doing that. I'll say I'm somewhere in the middle. I could pick one thing. I could pick one API and I could be like the best person who does that one thing. But that could run the risk of losing relevance or just being suited to one thing. So I want to talk about a story. This is something that really bothers me. I'm not an angry person. I'm pretty even-tempered, but there's one thing that really bothers me, and that's when I see pieces of evidence of people switching off critical thinking. This is something I call the cult of self-dot. Okay? If you have any Python experience, a lot of my work is professionally tutoring and teaching Python, and I see a lot of students come in when we're doing, for instance, object-oriented programming. I see this a lot of professional tutors when they're talking to students will say, okay, so you need to change this variable. So you write self dot underscore time equals 3 or something. You know what I mean? And it's these little words which are being used in a way where they are completely divorced from the actual meaning. Okay. And I sound like a crazy person when I talk about this because it's a very subtle difference. Saying things like self._health equals 100 is the most efficient way of conveying that information directly. It's the most efficient way if the person you're talking to is a gremlin and they're just going to, like if you forget to say underscore, they're going to forget to type underscore. Oh my goodness, I just remembered something. Okay, you know Rocky Horror Picture Show? You know those outings where people go to the Rocky Horror Picture Show and they riff on it? There's a specific, like, at this timestamp you meant to make this joke. At this timestamp you meant to make this joke. Like years ago I went and we were watching this and there was a projector issue midway through. So they stopped the projector and then they restarted it like a minute prior to where it had stopped or something. And the audience started making the same jokes from that exact timestamp. Oh my goodness, I just remembered that. That was horrible. It made me viscerally sick, made me want to vomit. Do you know what I mean? You sound like a crazy person talking about things like that. But then you look out there and some people really do believe that when you open a window on your operating system, that thing is like immutable and you can't resize it, you can't change it. What? Minimize? What? I just have like 20 icons down the bottom. So I guess the lesson I can take from the cult of self-dot is that there is a lot of value in using exact language, which is not literal, but it reflects the meaning of what's happening. So probably a better way to say set self dot underscore health equals 100 is to say, set the instance's health variable to 100. And if the student really has difficulty with that, say, okay, what is the name for the reference to the instance of the class? Or if that's a little too much, say, hey, what does self mean? What is the data type of self? What does self represent? Okay, now use the accessor. In Python, what is the accessor operator? To access, and you can give more examples, to access the variables and the methods of an instance. That sort of thing takes more time, for sure, but it really pays off because it encourages people to use critical thinking and to reason about things with precise definitions, because especially Python hides so much under the hood, and it's really not helpful. Another example, from years ago when I was teaching kids and we're doing math, things like numerator and denominator. What is the numerator? What is the denominator? A lot of students will tell you it's a number on top, it's a number on bottom. And those students have a lot of difficulty with abstract problem solving. In this case, as slow as it may be, I will force them, I force them to say, all right, well, the denominator represents the number of parts that something is being shared into, and the numerator represents how many parts it is being allocated. For instance, that's just off the cuff, but that's another case where using the precise definition, I mean, how can anyone problem solve without knowing the precise definition? I don't know. So, starting to wrap things up now, I just want to give an exercise. This is probably a good exercise. I call it information translation. One of the biggest things I see is a lot of people say, oh, right, great, you've explained how to do this thing. How do I do this other thing? But the other thing that they mention is just a slight variation on the original thing. This actually happens quite a lot in tutorials, and really good tutorials that I see, the person giving the tutorial will give exercises which are slight variations. I should probably do this more. I'm a little bit lazy with that. But here's the exercise. Get a programming, like Learn Programming 101 textbook, and don't read it for the information, read it for the exercises, but then complete the exercises in a different programming language. And I know that sounds a bit basic, but this is sort of basic advice for beginners, I guess. And just to end things, conclusion, okay, optimistic conclusion. The education system has failed, and that's your job now.